So today we are going to do a question from Irodov 1.249. We will do it on the basis of intuition, pure intuition. Okay. So what is given, that there is a disk, uniform disk of mass m and radius r. It's being rotated at an angular speed omega and kept horizontally on the table like this, and the friction coefficient is mu here. And they have also told us that the normal acting would be uniform over the whole disk. Like if a block is kept on the ground, then they are saying like so that here is dn, here is dn, here is dn, here is dn, all these are same components. Means at each and every dm mass particle there would be same normal force, and they will all add up to n, which would be ultimately equals to mg. Okay, because it will stay in the vertical equilibrium, mg, and normal will also act at the center of mass, so that the net torque is 0. Okay, so this was the initial analysis that we have to do when we just put it on the table. Now when we put it on the table, every mass particle is having a relative velocity. Suppose that okay, I have given it this way. So let's take any mass particle, let's say the mass particle here. So its velocity is here at some time, it's v into this r, v equals to omega into r. Okay, so table will try to deaccelerate it by providing a friction, and like this all the particles will experience the friction force like this. But the question here is we have to find how many turns it will take before stopping. Number of turns we have to find. So for finding number of turns, we will need how much angle it has covered in that period of time till it stops. So what we will do is, we will take a small element such that on that small element the friction force is same. What I am saying is, let's suppose that I take a ring, okay, and its radius is r, and this length is, thickness of the ring is dr. Okay, so the ring mass is dm. Okay, so consider very small particles here. Let's suppose this has n particles, n can be infinite also, but we don't care about that. What I'm trying to write now is that if n particles make dm mass, then one particle will have dm upon n mass unit. Okay, yes. So what we can write is, every dm by n particle, let's say I took a particle here, its velocity is this is rotating like this, so its velocity is like this, so friction will act like this. Same if I take here, velocity is like this, so friction will act here. This particle, friction will act here. This particle, friction will act here. This particle, friction will act here. So all the frictional forces will be anti-parallel to the velocities. And what the velocity in circular motion, the velocity is perpendicular to the radial vector. So I can say that on any dm by n particle on this ring, there would be a frictional force, and that frictional force will be nothing but f for one particle I am writing dm by n times what g, this particle, if I say the dm by n g force would be acting, okay, and there would be some reaction force, and our friction would be kinetic, so mu r I will write. So this is into mu, this is r and this is mu, okay. So this is for one particle of that ring, okay. Now what if I write torque about this axis, that due to friction how much the torque will be for the whole ring. So for one particle I know its friction force is this, and it's also perpendicular to the radial vector. So my torque for one particle will be dm upon n g times mu times the r, okay. And if I integrate it for all the particles, all the tau, all the torques acting here, so see, for any force I take r and f is like this for everyone. So r vector cross f vector, so its thumb is pointing down. So the net torque for all the particle, sum of all the particles, net torque would be inside the plane. Yeah, understood. So if I write tau of the ring element that we have chosen will be now see, if I see r is constant for this ring, r is constant for all the particles. What's the variable? This dm by n. So I am adding all the, how many dm by n particles are there? N particles. So n times dm upon n, so it would be cancelled out. So I will get dm g mu r, okay. For one ring element I can write the torque like this, okay. So now let us, this is for one element, we will now integrate it for the whole disk, okay. Let me see if I have missed anything or not. R cross f is the tau ring, will integrate this, yeah. So this will give us tau by the friction force acting on the body. Now see, all such rings, the friction would be nature of friction would be same, it would be acting like this, okay. Just r would be the different, and I can also write dm mass as sigma times the area of ring element. So it would be sigma times area of the ring element would be, the length of the element will be 2 pi r, and it would be multiplied by dr for the area, 2 pi r dr, okay. So I can substitute this here. Sigma is the mass per unit area density, okay. So it would be like sigma is constant, g is constant, mu is constant, 2 pi is also constant. It will come out of the integral r square dr. We have to integrate it, and all the ring elements from 0 to a radius r. So it would come out to be what? Sigma is mass upon pi r square into g times mu times 2 pi times r cube by 3 will be the integral of this. So we can see this would be gone, this would be also gone. We will remain with mu mg r by 3, okay. And this would be nothing but the tau by the friction on this. Now what we will do is that at any moment if I see the omega was this, alpha would be like this, because the friction is trying to oppose the motion. Alpha will be like this. So if I see any particle at some instant, it would experience a tangential force. I am writing the FBD for that particle, only the external force. It would have an let's suppose this is at a distance r, and the particle mass is, let's suppose, ith particle I am looking at, okay, and its radius vector is, let's say, ri. So its acceleration would be alpha times ri. This would be acceleration, and I will multiply it with its that mass. Okay, so what would be the torque about this axis on this? The friction acting, the torque was due to the friction, and I can write the friction is like this for this particle, mi alpha ri, because it's the tangential force that is acting, which is nothing but basically friction. So what would be the torque? Torque would be mi alpha ri into ri, because the force and the radial vector is perpendicular, alpha ri squared. So if I sum it for all the particles, I would get tau friction. This will be nothing but ri squared, and we can take the alpha out of that for that moment of time, and this is nothing but the moment of inertia of the ring. What is the moment of inertia of the ring? mr square by 2 times alpha. We can find the alpha by putting it here, and our question would be solved.